All right, tonight we're going to look at how do we prove whether or not two triangles are similar. So today in class, we looked at, in general, how do we tell whether two polygons are similar, and found out that all the angles have to be congruent and corresponding sides have to be proportional. They have to have the same scale factor. So for triangles, that would leave us having to check 6 pieces of information. So just like we did with congruence, we're going to learn shorter ways to do that, shorter ways to prove that two triangles are for sure similar. So the first one is angle. If two angles of one triangle are congruent to two angles of another triangle, then those triangles have to be similar to one another. So that is the first way to determine whether or not triangles have to be congruent, and that is called angle-angle similarity. You can also abbreviate that AA with a little similar sign afterwards. So for instance here, I could tell whether or not these two triangles are similar. I would need to know that, for instance, X is congruent to M, and also that angle Y is congruent to angle N. Alright, so I need 2 pairs of angles being congruent. And of course, if I know 2 pairs of angles are congruent, I also know the third pair of angles are congruent in a triangle. That's why we know for sure they have to be similar. Alright, so let's look at the next one. Side angle side similarity. This is exactly what you think it would be. It's a lot like congruence, except for these S's we have to be a little careful with, because here we don't need that sides are congruent, we just need that they're proportional. So for side angle side, if one angle of a triangle is congruent to an angle in another triangle, and the sides that include the angle, or the two angles, I should say, are proportional, then I know that the triangles must be similar to one another. And that is called side angle side similarity, or SAS. So for instance, what that might look like, say that I know here that angle I is congruent to angle Q. Then I would also need that IH over QP equals IJ over QR. Then I would know that those triangles are similar. So you would check that proportion. You could just reduce to see that they have the same scale factor, or you could actually cross multiply and make sure they equal the same thing. And then the last one is side-side-side similarity. So side-side-side similarity says that all sides must be proportional, or all pairs of corresponding sides must be proportional. Then, if that happens, I know that all those angles are, and I know that those triangles are going to be similar. I misspelled proportional wrong. All right. So those are the 3 different ways. So here, for that last one, I would need that AB over DE, or ED, equals AC over DF and that has to equal BC over EF. So let's look at some quick examples of that, and we are done. So here, I need to determine whether or not these two triangles are similar. So let's look at the first one. Here I don't have any side lengths at all. All I have is angle measures. So the only one of those theorems I could use would be angle-angle. So here I only have two angles in each. I know that L is congruent to M because, well, they're both 57. So if I need to find out this third angle to see if it's a possibility that these two triangles could be similar or not. So to do that, I could just do 180 minus 57 plus 48. And when you solve that, you get 75. So sure enough, angle K is congruent to angle P. So yes, these triangles are similar. So we would say triangle, LKJ triangle, is similar to triangle MPQ. And that would be by angle-angle similarity. So let's look at the next one. Here again, we want to figure out if these are similar. If so, how? So right off the bat, I see this pair of vertical angles. So I have one pair of angles being congruent. Again, I don't have any side measures, so the only way I could possibly do this is by angle-angle. But luckily, they gave us these little parallel marks here, so I know that these sides are parallel. So I know that, for instance, angle X has to be congruent to angle T because they are alternate interior angles. So yes, these are similar by AA. And again, you could write a little congruent statement for that. Triangle XSR is similar to triangle TSW. And then let's look at these last two really quickly. Here, again, we only have angle measures in both of those. So I'm actually going to move on, and we're going to find some where we have some side lengths. Okay, so here are two triangles where I have some sides. I wanted to use something other than AA in these. So let's look at the first one. The first two triangles, I have no angle measures at all. So I could not, for the first one, use AA or SAS. It just is not going to happen. So the only possibility for that one would be SSS. So I need to check that all three pairs of sides are proportional here. If they are, then those triangles are similar. So if I look at those, we're going to pair up small with small. So 8 is the smallest here, 6 is the smallest here. So 8 over 6 simplifies to 4 over 3. So then I can go medium in each. So 12 is the next smallest, 9 is the next smallest here. So 12 over 9. If I simplify that, I can take a 3 out of each. That would also be 4 over 3. So I have one more to check, 16 over 12. When I do 16 over 12, I can take a 4 out of each. That would be 4 over 3. So yes, these are similar by SSS, similarity. And then the very last one, here I do have some angles to work with. I don't have more than one though, so I can't use AA. I don't have all three pairs of sides, so I can't use SSS. So the only option here would be SAS. And I do have this pair of vertical angles that allows me to do that, and it is included in those sides. So again, we're going to do this one the same way. We just need to check that the sides are proportional. So the smaller side pairs up with the smaller side. So 10 over 20, that reduces to 1 over 2. And then I have 11 over 22, which reduces to 1 over 2 as well. So yes, these are also similar by SAS. So that is how you check. It's a little more complicated than congruence because you do have to check that those side lengths are proportional. I'll see you tomorrow.